Unit 3, Lesson 4, The Water Wonderland. In this lesson, we're going to look at some of the key ideas that we've discussed so far in this unit. Domain, range are going to be two of the big ones. Now, in this problem, Allie and Dane are both working at a water park, and they're going to drain the water at the end of each month for the ride that they supervise. Use a pump to remove the water from the small pool at the bottom of the ride. The graph given represents the amount of water in Allie's pool and Dane's pool. Allie is A of X, Dane is D of X over time. Number 1 says to make as many observations as possible with the information given in the graph. Well, just looking at the graph, one thing that might pop out to you is that there are no numbers. Nothing is labeled, really, at the beginning of the problem. Also, both graphs, both A of X and D of X, are negatively sloped. They're going downhill. And another thing that you might notice, A of X is faster than D of X. So Allie is draining faster. So her pump is pumping faster. A couple other things that you might notice, that at some point in time, both pools are going to have the same amount of water in them. There is a point of intersection. You're going to notice Dane's pool has more water initially. Allie has more water initially than Dane, but Allie finishes first. Okay, now, Dane figured out the pump he uses drains water at a rate of 1,000 gallons per minute, and it takes 24 minutes to drain. Well, they've told us a lot of information right there. So for Dane, his slope is negative 1,000 gallons per minute. That's how fast his pump is going. Also, tells us what this point is right here. This must be 24, 0, because that's when he has no water in his pool. And then from these two pieces of information, we can figure out this point up here, this intercept. It must be 24,000 gallons, since it takes 24 minutes at 1,000 gallons per minute. So this point right here is 24,000. So that's all we can figure out so far. Now, what is the equation draining Dane's pool? Well, think of it as what we did before, an arithmetic sequence. We know where it starts. It starts at 24,000. We know how it moves. It moves down by 1,000 every minute. And it does begin at 0 minutes. So D of X would be 24,000 minus 1,000x. Okay, number 3, we've basically done. Number 4, what values of x make sense? In other words, what's the domain? The domain is 0 to 24 minutes. And the output, the range, would be from 0 to 24,000. Now, for Allie's pool, we're going to do the same thing. It's not super clear here on this graph what Allie's intercepts are. Like, we can figure out one of them. This here is 20 minutes. But it's hard to figure out what the y-intercept would be here. There is another graph in this lesson. So if you look on the next page, right here, this is the intercept for Allie. That's 28,000. So let's go back to here. Let's go back to the original graph. We'll label that one as 28,000. We can figure out the slope of her line because it's 28,000 divided by 20. So, and it's going down, so it's negative. This is negative 1,400 gallons per minute. And now we can write the equation for her. So number 6, her equation is A of x is 28,000 minus 1,400x. Her domain goes from 0 to 20, and her range goes from 0 to 28,000. Now, depending on what class you're in, we might not have had time to get to this section down here, but this is where they decide to work together. If they work together, then we can just add their graphs together. So this is going to be 24,000 plus 28,000. That would be 24,000 plus 28,000. Lots of zeros. 52,000, way up here. And then at the place where they intersect, which is 14, let's see, is that 10,000, 12,000, 14,000, yeah. Well, we can just basically double that. If we're going to add that together, that's 28,000. That would be right up here. And then we can project where that's going to hit. So it's probably going to take them less time if they work together than if they work individually, because while her pump is done at 20 minutes, his pump still has to work for 2 more minutes. But if she gets assistance, or if she gives him assistance, then together they'll be able to finish the job in less amount of time. Okay, well, that's it for now, and we'll see you later.